On Fish Kill Day 2, we looked at the solubility of some cations and some anions. And again, cations are those who are going to lose an electron and have a positive charge, mostly metals here, you'll notice metals. And then you have your anions with some non-metals. They will gain electrons and have a negative charge. So we looked at some Java labs where we mixed together like potassium and chlorine, or potassium chloride. That produced no precipitate. And then we had cations and anions like silver chloride, where silver produced a white precipitate. So any of the blank boxes you filled out with the video, and then the Java lab was filled out with the Java lab activity, whether it formed a precipitate or not. Then down below for the homework was the analysis portion. So we want to use the table below and the results from part 1 to summarize our general solubility rules. So using this table that we have created, you're going to read this table and analyze it to figure out solubility rules. Not all listed in the rules were tested. So remember, some of these are part of the same groups on the periodic table, so it would have similar solubility properties. Those in pink were what we tested in class. The rest were part of that same group and have the same solubility rule. So, for example, in these, the ions, like we studied we studied sodium and potassium and ammonium. We studied those 3. So when we want to look at those 3 with any anion on your table, you'll look at sodium. The whole way across, it says no PPT. What that means was they are soluble and no precipitate form. We mixed the 2 clear liquids, and they were still 2 clear liquids. There was no white solid substance, yellow. There was no solid that formed. And you'll just continue that. And as we continue it, we looked at like some nitrates. If we came up here, nitrate mixed with ammonium, no PPT. Potassium was no PPT, same as calcium. All of our cations for nitrate had no precipitate form. So what that means is no PPT means it's soluble. So nitrate with any cation is going to be soluble. For hydroxide here, OH minus. For potassium, sodium, and ammonium, let's go check those out. So if we scroll up, for hydroxide, for potassium, no PPT. Sodium, no precipitate either. And then ammonia was clear for all of them, so it'd be no precipitate for all of them. So hydroxide, for those 3 cations, is going to be soluble. But hydroxide for calcium formed a precipitate. For magnesium formed a white precipitate. So what we're going to do is it's going to become insoluble when it forms a precipitate. That means it had some color and PPT next to it. And you just do the same thing for all of them. For chloride and silver. So if we scroll up to silver chloride, it makes a white precipitate. So that tells us that it is insoluble. Silver and chlorine together are insoluble. So if we scroll down, where it has chloride mixed with silver, you would put insoluble. And what that would mean was for the other cations, it's going to be soluble. So it's soluble for sodium. Chloride is soluble for potassium. So soluble in the other box. And you'll continue this just identifying patterns. If it says no PPT, that means it's soluble. That means no solid was formed. If it says white, yellow, like here, silver chloride is insoluble. Silver carbonate is insoluble. Those are 2 examples of what is insoluble. Arsenate is soluble with ammonium, potassium, and sodium. It is insoluble with all other cations. Is a description. These patterns are what we're going to use for our solubility rules to identify if certain cations and anions are soluble in that river water. So using these rules up here, you'll apply them to down below. So using the rules, highlight whether the following compounds are as soluble or insoluble. So if we have silver and iodide, on our table. So here's silver, here's iodine. I found both of them. You just got to find both, or sometimes just one. So silver and iodide is insoluble. So we would highlight I for insoluble, for silver iodide. Hydroxide, we have rules for hydroxide already. So if we have hydroxide and we're looking for magnesium. So for the soluble, is magnesium here? Magnesium is not found there, so it's part of the insoluble for the hydroxide. So that would be I as well. Potassium bromide. Let's look for potassium on here. Potassium with any anion. Bromide is -1. That is soluble. So a lot of this is just identifying patterns, first with what we came up with in class, building the table, and then you apply this table to different compounds that you're given. And then finally, you're going to answer, how do you think these rules could help you determine if lead, arsenate, and aluminum ions were in the river water? What could you do? How could these help you with testing? How could you help determine what to test? And that's how you'll fill out the solubility table. There is also a video on Schoology in Unit 8, Week 15 as well. And it's called Solubility Rules and How to Use the Table. That can also be very helpful on top of this.